Welcome back to a new tutorial on Unirack, my audiovisual modular synthesizer. So in the first video, I went over the overall structure and functionalities of Unirack. In this video, I will start actually making some work with Unirack, and in particular, I'm going to build the first patch and see how that's done. So here have an empty scene, and I can start creating the first objects that I need for Unirack to run. So I can create an empty object, call it, for instance, UR, and start adding. I need three scripts to be loaded on this. The first one will be the libpd instance, and the libpd instance does not need to have anything done to it except for loading an empty patch to it. So the patch that I'm loading, whatever I have in this patch will be overwritten. So it can be empty or it can be also not empty, but just so you know, you will lose whatever it's contained in the patch whenever I start building my Unirack patch. The second script that I need is the Unirack instance. Unirack instance is pretty much the most important script where I load all of my assets that will produce the Unirack patch. I need to select the is build patch option for Unirack instance to build the patch. The last script that I need for this is the viewer for the Unirack instance script. This is just allows me to have a consolidated view of all of the assets that are loaded into the Unirack instance. So it's pretty much just for UI objects, and I have to drag and drop my Unirack instance object into the Unirack instance editor viewer. So let's start opening some UR windows. So I have a UR Windows menu here. I can start opening the Unirack instance editor, which is a window that will again display all of my Unirack assets. And here I need to drag and drop the Unirack instance object that I want to display. Another window that I want to open right away is the module manager. This is a very useful window that allows me to instantiate object assets very easily, and the module manager actually is very helpful in keeping your project organized, because it will create a folder into the UR modules in your assets. So let's start creating a instrument. So maybe let's create an oxygen oscillator. You can see here all the instruments that I have available now. And whenever I select one in my module manager, it will automatically give the name of the scene underscore the scene name underscore the name of the kind of object you're creating. And if I hit create, it will create that object right here. You can see on the bottom left, it has created a folder scene1, and within that a folder instrument, and within that my oxygen oscillator. Immediately you can see how I have a few parameters appearing here. The most important one being the polyphony. So how many voices do I want for my patch? I'm gonna select 3 and it will automatically adapt all of the sliders to however many voices you have selected. And I might want to give some random values there too. And now that I've created this instrument, I can start loading the instrument onto the Unirack instance script, and I can go down to my patch build section of the Unirack script and start adding the instrument. For now, I just have one, but just just so you know, this is going to be 3 voices. So it's going to be one type of instrument, but with 3 voices. 15 maximum voices. Of course, the more voices you have, the more CPU will be. There is a second option, so to load, instead of one instrument, multiple instruments. If I have more than one instrument loaded in this array, then each instrument will be a different voice. I can have a polyphonic instrument or multiple monophonic instruments. And for instance, in the case of a drum kit patch, I can have kick, snare, and hats as 3 separate instruments. In that case, I will select Polyphony 1 for each. So I can, for instance, add a filter, and I want to select Polyphony 3 to match my instrument polyphony. And here I have cutoff, I have resonance, I have gain, of course, and a dry wet also. Then I want to add a control module, like a channel strip module. In the channel control submenu here, I can have a channel control, a simple channel control, PD block, again, Polyphony 3. And here I have just a volume. I have panning that I can set to the middle. And I can mute these if I want. And I also have some sends. I have 3 sends, send A, send B, and C, and I will give it some send to it. So now I can load these modules in the sound process part of my Unirack instance. So I will add 2 fields, one for the VCF and one for the channel control. And so now I have the instruments that will go into the VCF and the channel control. If I want to add an envelope also, I might want to have an envelope. So I can add an envelope generator. I have, in this case, only 2 kinds for now, ADSR and velocity. The ADSR is an envelope generator. Velocity is simply a velocity controller. So I'll create a ADSR, again, Polyphony 3. And this works exactly like an envelope generator with an attack, decay, sustain, release, and a gate in milliseconds. And now I can add that also to my sound process part. And I might want to have this to be first. So I want to select the ADSR first. So now we'll have ADSR, a filter, and finally my channel control module here. If I want to add an auxiliary send, then I can also select something in the process section. And for the auxiliary, the way it's set up is I want actually a stereo module, and the stereo modules are marked by stereo. For the auxiliary channels, actually, I'm not going to add polyphony, because these will be processing the whole, all of the different voices will be processed in one single module. And in this case, then I don't want to select any polyphony other than 1. Add that to my auxiliary field. Here I can add, and of course I can have more than 1. I can have a reverb and a delay or distortion, whatever you want. So I'm going to select the stereo pure reverb. This will be the totality of my PD patch. It will have a oxygen oscillator, ADSR, filter, channel control, and then auxiliary reverb. And if I play this, it will already generate the patch at start. So like I said in the first video, all control data in Unirack is generated by Unity, not by PD. So I will send note events from the sequencer to the patch using a control data module. Let's start by creating a sequencer here. So I go now not in the PD block, but in the rack modules, which are all of the control data generators and modifiers. And I can have a sequencer. I have at the moment I have 4 sequencers. Let's select the stochastic one, which is just a step sequencer with probabilities for each step. And now I do want a 3 polyphony for this one as well. And for this, I have the following parameters. I have the ramp frequency, so how fast the sequencer moves, and I can have different values for each voice. I can have different speeds for each of the voices. I'm gonna set it to 0.5 frequency, and I can change the phases of the ramps. The number of steps is decided here. Now you can see that these fields have changed, and these are my probability steps. All right, so these are just sliders that decide what is the probability for each one of these trigger to happen. I can load that into the sequencer. So if I start playing this patch now, I will have a PD patch being built. And if I double click on the patch field, this is what the patch in PD will look like, reflecting all of the fields that I have in my Unirack instance patch. So you can see a few things here. You can see how the polyphony is reflected by the number of note in objects and the number of copies of each one of the modules. And I have the auxiliary connected from the send outlets of the control channel object to be processed as a single object, like you would do in a mixer normally. All right, so I need to add another object to the scene in order for this to work correctly, and that object is a timer, and all of the time-based objects will refer to the global timer for clock. So now if I play this, not only will generate the patch, but I should start hearing some sounds. All right, they're all at the same pitch and at the same velocity because I haven't really created a pitch quantizer or a velocity quantizer. If I want to have a pitch quantizer, then I can have here, I can go here, and I have for now just 2. So I'll create that. I will give it a polyphony 3, and this will have a lower sort of a bound, a higher bound, right, for the range of pitches that I want to create. I have a key slider, so I can have, for instance, 3, 3, and 3, and now I can select which pitches are in the pitch collections. Within the pitch collection, it's built for each voices of each one of the voices. I can select one of the pitches with a slider 0 to 1. I can do that manually, but that will also keep the pitch fixed to 1 individual pitch. Or I can add my first patch bay, which will allow me to control pitch based on some control data. So I will open up the patchbays menu and select a patchbay object, which I will call In this case, since I want to create more than one patch bay, I will call patch pitch my sequencer as also a controller for my pitch. And the target would be my pitch quantizer, which is called mode. And immediately I have a way to sync the polyphony of the two. So now they are polyphony 3. So I can connect the sequencer to the quantizer. And what can I select? I can have one connection just to connect the ramp of the sequencer to any of the parameters of the quantizer. And I do want to select the select, which means that in the pitch quantizer, the note of the pitch array will be selected by the ramp of the sequencer. So I've created my patch bay. I need to load the patch bay into my Unirack instance. 4 kinds of connections that I can have. The updating of these modules can happen at frame rate, or what I call a sample and hold patch bay, which will only be evaluated when a node event happens. And in this case, this is what I want. And patch pitch will happen there. Oh, and I need to also have this here. So now that I have a pitch quantizer, I have to make sure that that's loaded into the Unirack instance. So I have now different pitches based on the ramp of the sequencer. So if I want to have a velocity quantizer, I need to go into the rack modules velocity, and I can create that, add a polyphony 3. In this case, again, I can select that automatically, just manually, just with a slider here, or I can create another patch bay to control the velocity. So I will still use the stochastic sequencer for a controller and velocity for a target, sync the polyphony, create one connection. So I will just give it a range for now. I have to add that to my velocity, and I have to add also the patch bay here, also as a sample and hold patch bay. And now the velocity of the node will be dependent on this other parameter. I can change the probability, of course. This will give me different outputs. So I can do this. I can add an LFO. And let's use a single LFO. I also have 4 LFOs, but of course it's actually 3 if I increase the polyphony. And in this case, I might not want to give it a frequency that is the same for all. So I could have something like that. Let's leave it as a triangular. Okay, so this is a new control data module that needs to run. So the rack modules that run at frame rate should be loaded into the FPS modules array. And in this case, I need to add my single LFO. And since the LFOs is a continuous shape, then I will need it to be running at frame rate. All right. So now this is going to be running the LFOs, but in order to control some parameter, again, I need to create a patch bay to make a connection. And in this case, I want this LFO to, for instance, control some parameter in the PD patch. And for a connection to the PD patch, I need to create a patch bay PD, and I will call this patch PD. And let's say I want with this to control the cutoff. All right. So I create that, and this will be, the controller will be my single LFO. The target will be a VCF, my filter, sync the polyphony, and create one connection since the LFO only has one output, which is the LFO output. And I can control the cutoff, or I can control the resonance, the gain, the dry wet. But let's say I want to control the cutoff, some range, and this will now appear also in, I will need to actually load it into my Unirack instance. And here I have the FPS patchbays PD. So if I want the filter cutoff to be continuously changing, I will load it into the FPS patchbay PD. Or if I wanted to only change node events, I will have to load it on the sample and hold patchbays PD. Let's say I want a continuous change. I will load that here. And now in my patchbay PD menu in my window, I will have that also. And I can also manipulate it there. So let's see if that works. Let's increase the resonance. So in the next video, I will go over how to make a patch for instance, drums with a multi-instrument setup. So instead of having one single instrument with polyphony, I will have different instruments within the same rack instance. But for now, this should give you an idea of how the Unirack environment works and how flexible it is. And eventually we're gonna add also the visualizers, which will work in a very similar way, using patchbays and using different modules to control parameters. So thank you for tuning in. Until the next time, take care.